Module 8.1. As a reminder, it's recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 8.1. How can we numerically describe quantitative data? In the previous modules, we discussed ways to summarize data. We need to summarize data because saying something useful about raw data can be difficult, if not impossible. Recall there are two ways we are going to classify variables: categorical or quantitative. Previously, we discussed summarizing categorical data with both descriptive statistics and graphs. Additionally, we looked at graphs for quantitative data. In this module, we'll continue looking at quantitative data. Recall, when describing a quantitative variable, we considered these following questions. What is the general shape of the data? Where are the data values centered? And how do the data vary? To illustrate the summary of quantitative variables, let's review the serial data set we looked at previously. Located in the script is a website which hosts many interesting small data sets. One of the data sets on the website has information about different types of cereal and their dietary information. A file of the data is provided for you on Canvas. Also located in the script are the variables contained in the data set. How can we summarize the center of a quantitative variable? One way to summarize a quantitative variable is to look for a measure of center or centrality. A measure of centrality tells us about the center of the values of a quantitative variable. There are many different ways to measure centrality, and you are probably already familiar with some of them. The mean is one of the most commonly used statistical summaries. It is also known as the average. Located in the video script is the formula for the mean. The mean is one possible measure of the center of data. The mean can be sensitive to outliers. A note on notation: the symbol x bar is used when the mean is calculated from sample data. When we calculate the mean from population data, we use the symbol mu. The median is another common measure of centrality. To find the median, the observations are arranged from smallest to largest. The median is the middle number of the ordered data. If there is an even number of data points, the median is the average of the two middle numbers. The mode is the value that occurs most often. The mode is only useful if the quantitative variable takes a few values. We will look at the variable sodium in the cereal data set. First, notice that there are 77 different types of cereal in the data set. This tells us there are 77 types of cereal in the sample, and that n is equal to 77. The values of the variable sodium are given in the video script. First, we will calculate the mean, the median, and the mode by hand. To calculate the mean, we first want to add up all of the numbers in the table. Adding all the numbers in the table together, we find that they add up to 12,295. Next, we divide the 2,295 by the number of cereal types, 77, and this gives us that x bar is equal to 159.68. To find the median, we first need to arrange the data from smallest to largest. Below is the data arranged from smallest to largest. Next, we want to find the middle number of the arranged data. In this case, there is an odd number of data points. The middle number is 180. Therefore, the median is equal to 180. Mode. Looking at the data in order, we see that the number which appears the most is 0. Therefore, the mode is 0. Take a moment and pause the video. See if you can calculate the mean, the median, and the mode of the following sets of test scores. Round if necessary to the nearest tenth. When you come back, we'll check your answers. To find the mean, we add up all of the test scores together and divide by the total number of test scores, which is 8. This gives a mean of 79.25. To calculate the median, we arrange the data from smallest to largest. Notice that this data set has an even number of data points. To find the median, we average the two middle numbers, giving a median of 82.5. To find the mode, we find the value which occurs the most often. Both 74 and 86 both occur twice, which is the most common number of occurrences. Therefore, the mode is both 74 and 86. Which measure of centrality should I use? Notice that the mode in the sodium example was 0, which does not give us a good idea of where the center of the data set is. The mode only tells us the most common value of the variable. For this reason, the two most common measures of centrality are the mean and the median. One advantage that the mode does have is that we could have used it with categorical data. The choice of whether to use the mean or the median depends on if a data set contains outliers and the shape of the distribution. Outliers are data points that are very large or small compared to most other data points. They are extreme data points. One way to detect outliers is to look at a plot to see if any of the points look extreme compared to the others, or for large gaps in the values. Later, we will look at numerical ways to detect outliers. When a data set contains outliers or has non-trivial skewness, the median is typically used as a measure of centrality. When a data set does not contain outliers and is roughly symmetric, the mean is typically used as the measure of centrality. The reason for this is that the mean can be greatly influenced by outliers, whereas the median is not. We say that the mean is sensitive to outliers. For example, suppose that 10 people are sitting in a coffee shop. The net worth in thousands of dollars is listed below. The mean of this data set is $18.9 thousand and the median is $19,000. Regarding net worth, there is not much difference in the value of the mean and the median. Also notice that none of the net worth values are extreme compared to the rest. Now suppose that Elon Musk, with a net worth of $2.6 billion, walks into the shop. The new data set is as follows. First, notice that Elon Musk's net worth is extreme compared to the others. It is an outlier. The mean of this new data set is $181,835,036, and the median is $20,000. Regarding net worth, there is now a considerable difference in the value of the mean and the median. The mean was strongly influenced by the introduction of the outlier, whereas the median did not change much. Additionally, notice that the mean is higher than the net worth of the original 10 people and lower than the net worth of Elon Musk. The mean does not give a descriptive summary of the net worth of the people in the coffee shop. The median, on the other hand, does give us a good summary of the majority of the net worth values. Your turn. A class of kindergartners are playing on the playground. Their teacher walks over to the students. When the teacher joins the students, does the average height or the median height of people on the playground change more? Notice here that the mean will change more. The teacher's height will be an outlier compared to the height of the students. Therefore, the mean height will change more compared to the median. Do I have to calculate the values by hand? No, there are many ways to calculate the mean, the median, and the mode. You can use an online app, you could use software, or many calculators have a program to calculate the mean, the median, and the mode. This ends the Module 8.1 video.